Hello everyone, welcome back to Physics HQ. This is Professor Sandeep, your tutor for the class 12 series. Continuing with the lecture series of solving MCQs and sums of class 12, today we'll be covering MCQs of chapter 7 Wave Optics. So let us check out the first MCQ. Which of the following phenomena proves that light is a transverse wave? Reflection, interference, diffraction or polarization? So the correct option over here is polarization. Let us first understand what is transverse wave and then we'll talk about polarization. So a transverse wave is a wave in which if it is traveling along x-axis, the particle on the wave will be oscillating in a direction perpendicular to the direction of propagation. Let me reframe it. Wave is traveling along x-axis and the particle over here, particle on the wave will be oscillating in a direction perpendicular to the direction of propagation. That is why it is called as transverse wave. The best example is if you throw a stone on a still water surface, what happens is we see that ripples are created and these ripples travel. You can see that the water molecules over here on the surface, they oscillate up and down and the wave is traveling in this direction, right? Hope you all understood this. Now let us talk about polarization. So polarization is a process in which unpolarized wave is converted into a polarized wave by means of a polarizer. What do you mean by a unpolarized wave? Let us understand with an example. So this is the wave that we discussed just now. Wave is traveling along x-axis and the particle is oscillating up and down instead of going forward, right? So that is why this is called as transverse wave. Now it is not necessary that the inclination should be perfectly vertical. The inclination of this wave can be somewhat like this at a particular angle, or the inclination can even be like this. Okay. Now if I try to draw this in terms of vectors, let us say this is the red wave which is vertical, perfectly vertical. Then you have this blue wave which is at some angle, let us say 30-40 degree. Then you got this black wave which is almost horizontal. And then let us say there are many more waves which are not exactly having vertical orientation. So this kind of wave is called as unpolarized wave. Now the job of this polarizer is to pass the waves which are having a particular orientation. Now in our case, the opening in this polarizer is vertical, so it will only allow waves which are having vertical orientation. So when we pass these waves over here, what we will get is we will only find that the red wave is able to pass through and come over here. All the other waves which are not having vertical orientation will be blocked by this polarizer, and this tells us that the particles on the wave, they oscillate in a direction perpendicular to the direction of propagation. Therefore it got blocked in this polarizer over here, and hence polarization can prove that light is a transverse wave. Hope you all understood this. Let us check out the next MCQ. Which property of light does not change when it travels from one medium to another? Velocity, wavelength, amplitude or frequency? The correct option is option D. Frequency does not change. The best example is the mobile communication. Now if you have a mobile tower somewhere nearby and you are in your house, then even though the windows are closed, doors and windows are closed, you receive the signal in your mobile phone. So these waves travel through this glass windows and reach to the mobile inside the home. And the mobile tower and mobile phone, they talk on one particular frequency. So if the frequency will change while passing through glass or other medium, then in that case we won't be able to receive the signal properly, but we are able to receive the signal properly, and this proves that frequency does not change while passing through one medium to the another. Hope you all understood this. Let us check out the next MCQ. When unpolarized light is passed through a polarizer, its intensity increases, decreases, remains changed, depends on the orientation of the polarizer. As we have seen in the first question, when we pass a unpolarized light through a polarizer, what happens is not all the waves are allowed to pass, only the one which is in the orientation of the polarizer can pass through it, and therefore the intensity of the light over here decreases. Hope you all understood this. Let us check out the next MCQ. In Young's double slit experiment, the two coherent sources have different intensities. If the ratio of maximum intensity to the minimum intensity in the interference pattern produced is 25:1, what was the ratio of the intensities of the two sources? Options are 5:1, 25:1, 3:2 or 9:4. What we are given is ratio of maximum to minimum intensity is 25:1. We know that maximum to minimum intensity का ratio can be written as A1 plus A2 the whole square upon A1 minus A2 the whole square. Now this is equal to 25/1. A1 and A2 are the amplitudes of the two coherent sources. We can take square root over here. What we will get is A1 plus A2 upon A1 minus A2. This is equal to 5/1. When we cross multiply, we will have A1 plus A2. This is equal to 5A1 minus 5A2. If we take 5A2 on this side and A1 on the other side, we will be left with 6A2. This is equal to 4A1. And when we write this in the ratio of A1 by A2, we get 6/4, which is nothing but 3/2. Now we are asked to find the ratio of intensities. So intensity of the first source to the intensity of the second source, this will be equal to amplitudes का square. So A1 का square upon A2 का square. So this will be equal to 3/2 the whole square, which is nothing but 9/4. So the correct option is option D. Hope you all understood this. Let us check out the next MCQ. In a Young's double slit experiment, a thin uniform sheet of glass is kept in front of the two slits parallel to the screen having the slits. The resulting interference pattern will satisfy. The interference pattern will remain unchanged. Fringe width will decrease. Fringe width will increase. The fringes will shift. Now in this case, what is happening is the uniform sheet of glass is kept in front of both the slits. So the light coming from both the slits will be following the same path difference, and therefore the interference pattern will remain unchanged. Hope you all understood this. Thank you for your time. If you are finding this lecture series useful, then show us your appreciation by clicking on the like button, and don't forget to share it with your friends and classmates. And as you know, based on your feedback and suggestions, we'll be covering key concepts under our 5 minutes lecture series of class 12. So please feel free to let us know the topic you want us to cover. See you all in the next class. This is Professor Sandeep from Physics HQ signing off.